All right, here's our video for our second day of SHRATEY examples. In this lesson, we have to do factoring before we can try and simplify. So I'm going to factor the denominator using my cross, so it multiplies to negative 12 and adds to negative 4. And that is negative 6 and 2. So here's my factored form. There is nothing to cancel, so I don't have any wholes. For roots, I set the denominator equal to 0 and solve. So my root is 0, 0. For vertical asymptotes, I set each of the factors in the denominator equal to 0. So that's x minus 6 and x plus 2 and solve them. And graph. So vertical asymptote at negative 2 and 1 at 6. T is for tangent over together, so in the numerator my factor is not squared, so no, it's not going to be tangent. And looking at these individual factors, neither of them are squared, so it's not together at x equals 6 and not together at x equals negative 2. In behavior, I look at my leading terms. I'm comparing the exponents, not the coefficients. Exponent on the bottom is bigger, so this is bottom heavy, which means my horizontal asymptote automatically is y equals 0. And then the y-intercept, since my x-intercept is 0, 0, I know that my y-intercept is that as well. So our next step is to figure out the first piece to lay down. So I know that because I have two vertical intercepts, I'm going to have 3 pieces. And I have a point already in the center piece. So I know that this shape is either going to be an x cubed or an x squared. And the way I know which way it's facing is, or which shape it is I look at my t step right here. So in my root information, we said it's not tangent. That means it's going to cross through. So I just need to know which way is that x cubed going to go. Now I don't have enough information right now, so I need to do a test point. I'm going to choose x equals 1 because it's easy to do math and it's right there in my middle spot. So I plug 1 in every place I see in x. Be sure you're doing your order of operations correctly. 1 squared at the bottom is 1, and then do your multiplications. It's going to give me negative 2/15. So my test point is 1. So if I go over 1, I don't need to know exactly what negative 2/15 is, just that it's below the x-axis. So now that I have these 2 points and I know my shape is an x cubed, I can fill that in here. Now I know my end pieces are going to be L shapes. I just need to know how their behavior is going to be on either side of the asymptote. So I look at my asymptote information. For x equals 6, I said not together. So here's where x is 6. So if it's down on the left, it's going to be up on the right. So now there's where my L shape is there. And then at x equals negative 2, I said no, not together. So if it's up on the left, it's going to be down on the right. For number 2, we are going to factor the numerator and the denominator using cross method. So in top, what multiplies to negative 2 and adds to negative 1. In the bottom, what multiplies to 1 and adds to negative 2. So I've got my terms, so that's going to give me x minus 2, x plus 1 on top, x minus 1 on bottom, and nothing cancels out. So this is where I'm at, so that means no holes. For the roots, I set the individual factors equal to 0 and solve them. So the factors from the numerator. Write them as ordered pairs and graph them. Then my asymptotes, they both happen to be the same thing, so I only need to solve it one time. And graph it. T is tangent over together. Now, you're not looking at the squareds in the original factor. These are in the original equation. These are not factors, these are terms because they're being added or subtracted to other things. What you're going to look at is the individual factors in your factored equation. You're looking, is this group squared? Is this group or factor squared? So none of them are squared. So it's going to be not, no for not tangent at 2, 0 and not tangent at -1, 0. Same on the bottom. At this asymptote, it's not together, and at this asymptote, it's not together. And then the end behavior, take your leading terms in the original equation. That's a balanced situation, so we simplify it to 1. So my horizontal asymptote is y equals 1. And then the y-intercept is where you plug 0 for all the x's. That's going to give me -2. So I have enough information here to draw all my shapes. This has one vertical asymptote, so it has 2 end pieces. They're going to be L-shaped. And does it make sense that they would come together? Did we say in our T-step that they would come? Oh, I messed up this whole one. Dang it. Hold on. So we're going to use this as a learning opportunity. What I was doing here was checking myself. Does it make sense that I said that they were going to come together? And I said no. I said no, and I said no here. But here's what I did wrong. I didn't slow down and realize these are the same. So really, this is x minus 1 squared. That means that I need to change my answer here to a yes, because I only have the one asymptote. I don't have 2 separate ones. So the one asymptote, that factor is squared. So this is a yes, it's going to come together. So it makes sense that my graph looks like this, even though I did the information wrong over here, but that's how I found my mistake, was using the information to cross-reference each other. So it's still kind of a win, not a full lose. All right. Number 3. So factoring the denominator, what multiplies to -6 and adds to 1, that is 3 and -2. So I've got 2x squared over x plus 3 times x minus 2. Nothing here cancels, so I have no holes. The root, you can set the top equal to 0 and solve. Remember, you can also factor the top as this, 2 times x times x. So you can set 2x squared equal to 0 and solve it, or you can say, oh, I'm going to set my x factors equal to 0 and solve them. In either case, you're going to still get 0. So my root is 0, 0. And if my x-intercept is 0, 0, so is my y. Asymptotes, take the individual factors and set them equal to 0. and graph them. There's one at -3 and one at 2. For tangent over together, my root 0, 0 comes from x squared. So that is squared, so this is going to be yes, tangent at the root. And then I need 2 answers in the denominator, looking at each of these factors. Neither one of them are squared, so it's no for the first asymptote and no for the second. It will not be together on either side. And then end behavior is the leading terms. Compare their exponents, they're the same, so that's balanced. So we simplify to 2, and that is my horizontal asymptote. So now we see if we have enough information to get started. I know that at the root, it's going to bounce. I just don't know if it's going to be bouncing up or down. And we talked about how avoiding the horizontal asymptote isn't sufficient to decide, because the horizontal asymptote is for end behavior only, as x gets really big that way and really small that way. In the middle, it doesn't have that much of an effect. So feels like it should be pointing down, but we do need more information before we can be sure. So how do we get a second point? We do a test point. And I can choose x equals 1 again here. So you can go to your original equation or the factored form, plug 1 in for all the x's. Two over -4, so -1/2. So I have a point at 1, -1/2. So once I plot that point, now I know which way it's going to bounce in. Yes, it does bounce away from the horizontal asymptote. And then our other 2 pieces are going to be the L-shaped pieces. We said at the individual asymptotes, it's not together at x equals -3 and not together at x equals 2. So if it's down on the right, it's going to be up on the left. And this one's down on the right, so it's going to be up on the left at this side. And I'm going to make a video for the last problem.